Okay, today we'll go into the new data type. The last data type what we have interface. Second. We'll see the new data type today. The last data type of Java, interface. So interface is also one more data type in Java. Okay, interface is also one more data type in Java. See, Java has got 4 data types. Java has 4 user-defined data types. Okay, the first one is class. The second one is subclass. Okay, the second one would be subclass. The third one would be abstract class, which we have covered. All the 3 we have covered now. The fourth one what we are going to see now is interface. So interface, okay, is also one more data type. See, all these 4 data types have been provided by Java to implement OOPS only, nothing else. Only scenarios will vary. In some scenario you'll go for class, in some scenario for implementing OOPS now. In some scenario you'll go for class, in some scenario for implementing OOPS you'll choose subclass. Some scenarios you'll choose abstract class, some scenarios you'll choose interface. Okay. So see, now we'll learn how to use a class. Then later on we'll learn how to use an interface today. Then we'll go on to discuss what is the difference between all these 4. But to give you just slight overview, classes are used for doing what? New concrete implementation. This is used for adding or subclass is used for adding or changing implementation. Abstract class is used for partial implementation, and this is used for doing no implementation. Means there will be no implementation at all. Okay, so it is completely open for implementation. See, abstract class is partially open for implementation. Abstract class is partially open for implementation, but an interface is completely open for implementation. Completely. Understood? So we'll see it. Actually, if I tell you those technical things, you'll not understand now. Better is we'll start seeing with an example. Then you'll start understanding all these points very clearly. So first, again, in interface also what I have to teach you? How to write an interface. Correct? How to write an interface, then how to use the interface. Same thing, story will continue. Then we'll see how it will be supporting to implement OOPS. How interface will help you to implement OOPS, that we'll study next. Are you clear with all this now? Okay, so we'll start off now. So it's a very rich data type. Interface is the most powerful data type Java has got. And because of interface only, Java's abstraction level has become very high. So the interface provides very high level of abstraction, and it also supports dynamic polymorphism in a very big way. Very, very big way. Dynamic polymorphism. Okay, so we'll start seeing with examples itself. So let's see the syntax now of an interface. Syntax. What is the syntax? You have to write this data type, you use on keyword now. To write this data type, you use on keyword called as interface. This is a keyword. Then you'll have a name. Then same, you'll open brace. Okay. Then you can add your members. But the only members what an interface can have are only 2. An interface data type can have only 2 possible members. That is public static final variables and abstract methods. Apart from these 2, an interface cannot contain any other member. You know what are the various members? Blocks, constructor, concrete method, static method, so many are there. But an interface can contain only 2 members, 2 type of members. What are they? Public static final variables and abstract methods. That's it. So what it can contain now? It can contain variables, data type, variable name, and value you have to give. And one more thing what it can contain is abstract methods. It will have a return type, method name, parameter list, that's it. So these are only 2 members. Okay, so this is the syntax. Example for that would be, say this, interface. You can have a name called as hello. Then I can write int x is equal to 10, int multiply int a int b. So this is the example for that. Understood? See, this is how you write an interface. When you code now, this is how you write, and you'll be saying this as what? Once you write this, you'll say it as hello.java. The file name would be hello.java. So once you compile this, okay, once you compile, again here also what will you get? A dot class file only you'll get. You're going to get a dot class. So you compile any data type in Java, you compile a class, you compile a subclass, you compile an abstract class, or you compile an interface. Finally what is generated? Dot class only is generated. Okay, so the name of the data type dot class gets generated. But what is going to be there in the data dot class file now? See, here if you have noticed, I told you, while telling this I told you, an interface always contains public static final variables. Okay, but did I write public static final here? No. So if you don't write, implicitly the compiler will make the variables as public static final. Implicitly, you don't have to do it. Compiler will add public static final for the variables. So it will have, see, you have written it in .java like that, but finally in the dot class it will be said like this: public static final int x is equal to 10. So it will be generated, code will be generated. Okay, so public abstract int multiply int a comma int b. So your dot class file, this is how the code will be generated now. You getting it now? You are getting the difference between your .java and dot class. So if you are interested in your Java file also, you can write what? Public static final you can write. If you are interested, you can write here. Okay. If you here also, if you are interested, if you want, you can write for the method also, public abstract. See, for variables you can write public static final. For methods you can write public and abstract. If you don't write also, no problem, compiler will add it by default for you. So it is optional. Writing these two things is optional for what? An interface. If you write it also, no problem. If you don't write also, it will be implicitly added. No problem. Who will add it? Compiler will be adding it. So compiler adds, okay, the default what? Values. Compiler adds public means static final for variables and will add public and abstract for methods. These are the two things it will add. Which one? Who is adding this? Compiler. Public and abstract for methods. Compiler is adding now. Are you clear this? Okay. So just I gave a minimum introduction. So still more we'll see now. That's the syntax. This is one example. And once you compile, this is what is getting generated. So we'll take a good example now and we'll start seeing. But remember, before that, an interface can contain only two members. Two means, don't think only one variable and one method now. Any number of variables, any number of methods. But it can contain, they can be only of two types. Two types means only public static final variables and abstract methods. These are only two types of members it can contain. Understood? It cannot contain what? Instance variables. It cannot contain blocks. Let it be instance block or static block. It cannot contain constructor. It cannot contain concrete methods. So possible members in an interface now. Possible members of an interface. That's it. Members of an interface. What are the possible members? Public, static, final variables. Second would be public, abstract, method. So interface can contain only two types of member. So it can contain members of an interface. Interface cannot, members of an interface. Now, interface cannot contain what? First one, instance variables. Second, what it cannot contain? Blocks. Both blocks, static and instance. Third, what it cannot contain? Constructor. Fourth, it cannot contain what? Concrete methods. Now, concrete methods are of two types, static and instance. So these are the members your interface cannot contain. Clear? Contain following members. Yeah. So if you see an interface is completely abstract, it does not have any implementation. An interface is completely abstract, it does not have any implementation, but it sets the standard for other classes to complete the implementation. An interface will not contain any implementation. It's completely open for implementation, and it sets the standard for other classes to complete the implementation. That's how an interface will be used. Clear? So let's clear this. Shall I remove all this now? Okay, let's see an example now for an interface. See, I'll take a very simple example. Interface A is there. It will have one method called as void m1. First I'll only deal with methods, then I'll go with variables. Following now? First I'll show you only having abstract methods. This is how an interface looks. It can, possible members are only two, you know that. Among that, one we are picking is abstract method, so it will not contain any implementation. Okay, so next, since it does not contain any implementation, it is not a concrete data type. So you cannot bring, and one more thing you know in Java now, okay, or in real life also you cannot bring unclear things into existence. Similarly in Java also, you cannot bring unclear things into existence. So here unclear things are called as abstract. Okay, so since interface is completely abstract, you cannot create, or it's unclear. An interface is completely abstract means what? It's unclear. You cannot create an object of interface also. Why it is unclear? Because it is not containing any implementation. An interface is unclear because it does not contain any implementation. That's why it is termed as unclear. Okay, but you cannot, that's what, you cannot create an object of an interface now. Let's see this. Class demo PSVM. See this, A is equal to null. See, you can definitely declare, this is possible, you can declare a reference variable of type interface. This is 100% possible. You can declare a variable of any data type. You can declare a variable of any data type, but you can't create an object. A is equal to new A is error. This is error. You cannot create an object of interface. Why you can't create an object of interface? Because it's unclear. It's unclear. Unclear things cannot be brought into existence. Okay, so understand the meaning between abstract and abstraction. Abstract means unclear. Okay, this is an unclear data type. But interface is again used for what? Achieving abstraction. It itself is abstract, but it helps you to provide what? High level of abstraction. That's what is the meaning. That's that meaning of the statement you have to understand now. So abstract interface is an abstract data type which is used for achieving abstraction. I'll be showing you that. Okay, it itself is unclear, but it supports you in implementing what? High level of abstraction. That's the meaning of it. Means, see, interface is an abstract data type. Abstract data type, but helps in achieving very high level of abstraction. Now this is one point. Now second point would be interfaces support dynamic polymorphism. Dynamic polymorphism. Hence, it supports abstraction in a big way. You understanding now? Hence it supports abstraction in a big way. We'll see this. These are 2 points. Just make a note of this. We'll start understanding these 2 points in depth now. I have to give examples for this. To make you understand these 2 points, I have to give again examples. Okay, I'm clear of everything now. Should I clear these 2 points now? Okay. So you cannot create an object of an interface. So what you will do now? So the only way we can means Java allows you to create objects of only clear things. Means anything which is clear, you can create an object. So you have to make them clear. What you have to do? You have to give the body for the methods. So you cannot give the body for the methods here. Okay, what you have to do? You have to use a class now. So let's see how you complete it now. So class Z implements. What I'll write? A. Class Z implements A. So I'm using 2 keywords today. I'm introducing 2 new keywords. One is interface, other one is implements. So an interface data type is designed with the help of interface keyword. Class data type is designed with help of class. Subclass data type is designed with the help of 2 keywords, class and extends. Okay. Abstract class data type is designed with 2 keywords, abstract and class. Interface data type is designed with the help of a keyword called as interface. So which data type you want to design, you have to use the appropriate keywords now. Understood? So you understand a class, if you data type, class keyword. Abstract class keyword, abstract class data type, abstract and class keyword. Subclass data type, class and extends keyword. Interface data type, interface keyword. So we have done it. Next, class Z implements. One more keyword we are seeing now. Implements interface. So what will Z do now? Void M1. It will do the implementation. Sorry. So we are giving the body now for the methods. So it only, I told you, interfaces are open for implementation. Correct? One point I told, interfaces are open for implementation and they set the standards for other classes to complete the implementation. So class Z is actually completing the implementation for what now? Interface. It is completing the implementation. So how is it completing? By giving the body for the 2 methods. As simple as this. So void M1. Then one more method is there. Void M2. Finished. SOP inside M2 now. So yes, class Z is the concrete implementation for the interface A. So I told you one point. Interfaces do not contain any implementation. They set the standard for other classes to complete the implementation. I told this point. Now we are revising that point. See here. Interface is there. Class Z is completing the implementation for interface A. Okay, it is completing. Now what will I do? I can use Z class also. Means Z is a concrete class. I cannot create an object of A, but definitely I can create an object of Z because it is concrete. Understood? So what will I do now? See this. I can say new Z. But Z is a class, remember. Interface is, this is one data type. I am using class data type. I am using class data type to complete the implementation for interface data type. I am using the class data type to complete the implementation for interface data type. So I am creating an object of which one now? Z. Okay. And once I create you can declare a variable also of type Z. You can also declare a variable of type Z. It's a class. You know how to work with the class. You know how to work with the class now. So Z is equal to null is valid. Z is equal to new Z. An object of what is created? Z is created. So once an object of Z is created, now let's see M1, M2. So it will also have the abstract methods from which one? Sorry, M1 and M2. So this is the Z object. So an object of which one is created now? Z is created. So once the object of Z is created, I can call the methods Z.M1, Z.M2. It will execute. So you know how to work with Z. There is no problem with that. Okay. But one more thing also I can do. A is equal to Z. Now we are coming back to our old story. Which one? Superclass referring to subclass object. So now see A.M1 valid, A.M2 valid. Now that address, see Z was here. I couldn't not create an object, but the value of Z I can give it to what? A. The value of Z I can give it to A, but that value is nothing but what? Reference value. The value of Z is nothing but reference value. So the address of this object I can give it to the variable of type A, and now A can call also both the methods. So and they get executed from the bottom. Understood? Criteria for overriding you know now. object. Yes. Now let's come back. See, when the class is implementing the interface, actually it will be overriding the methods present in the interface. Are you clear with this? We are giving the body is nothing but what? Overriding. Class A is actually overriding the methods of the, class Z is overriding the methods of interface A. So when you override, you know the rules. What are the rules? What are rules? If you're coming to the access specifier, if you're having one access in the superclass, if you're having any access specifier in the superclass, in the subclass when you override, it should have an equal or higher access. Since by default all the methods of your interface are what? Public. So any method you override of an interface should be mandatorily public. Mandatorily, compulsory, otherwise you'll get what? Error. If you don't use this one here, you'll get error. Are you following now? You understood how it works? So actually if you're seeing now, we are actually overriding. What are you doing actually? We are overriding the methods of the interface A in the class Z. And all the rules of overriding get applied here. What are the rules of overriding? Method name, return type, parameter list, higher access, equal or higher access. All the rules what you learned for overriding is getting applicable here. So this is how actually it gets executed. Are you clear with this? And finally, I can also convert this formula into what now? A is equal to new B is a highly valid code. Yes or no? Under what conditions? The possible conditions are, one condition, if A is a superclass, then B will be a subclass. This is one condition. If A is an abstract class, then B also will be what? Subclass. Number 3, if A is an interface, then third one, it will be a class implementing the interface. Remember that. Understood the 3 possible conditions? So this is true. A is equal to new B is true. Under these 3, class should be compulsory. A class, it should be a class implementing the interface. Here I have used Z. Don't think, look into this. But I am talking about the formula. A is equal to new B is a highly valid statement provided A and B are related in either of these 3 conditions. Understood? The possible chances can be what? If A is a class, then B has to be a subclass. If A is an abstract class, then B again has to be a subclass. Then if A is an interface, then B should be a class implementing the interface. Under these 3 conditions, it will be true. So A and B have to be related under these 3 conditions. Else it is error. You get the compilation error. Why? Because they become dissimilar data type. You cannot create an object of B and give it to the reference value of type A. You cannot create an object of, see, A is equal to B is valid under these conditions. If they are not related, how will you give the value of B object to A variable? So it will not be possible. Are you clear with this? And this is where dynamic polymorphism starts off now. So what is happening? You are creating an object of Z, but referring it with which variable? A variable. And you are working with Z object. Supposing example now, I set the interface, I write the interface, I don't want to do any implementation. So I'll set the standard and I'll make you do the implementation. And I'll use your code. What is that? Abstraction, no? I don't know how you have written the code, but still I'm getting the output. I'll give the next example for that. Clear? So we'll see how to code this now. So this is where the interface data type starts off now. Okay. It's the most important data type. Very powerful data type. Most important, most powerful. It is because of this data type Java is very rich. Understood? Shall I clear all this now? I'll do one thing. See this. I'll just write on interface. Interface A. And I'll write void M1. That's it. And I have to save it now. While saving, I will give a name called as interface demo, because my class containing main method will have this name. My class containing main method will have this name. Okay, so that's why I'm giving the name as interface demo.java. Fine. But actually, if you see, there's only an interface here. Understood? So let's see this now. I'm going to compile. Let's compile. This is the source code .java file. So when I compile this, dot class is generate. Sorry, where did I save this? I think I saved it in a different location. Okay, I'll put it in the folder called as. I'll create a new folder. While saving, I'll save it as interface demo.java. Are you clear? Just I saved it in a different location. I put it back into this interface folder. Fine. Save. So now see, I'll compile. So this is your folder. I'll just show you the DOS. In the Windows you can see now edit plus example August 2013. Yes, you go to your folder location. I saved that file here. Okay, so how many files are here now? Only one file .java, nothing else. So let me compile. See, after the compilation is done, you can go and see there. What is there? Dot class. File name is different, but the name of the class dot class gets generated name depending on the name of the data type. See, file name is different. Dot class file name will be different. Dot class name will always depend on the name what you have used for data types. Dot class will always depend on the name of the data type. Understood? .java file is different. That's your file name. So you should always be careful with your file name and data type name. Dot class always depends on the name of the data type. Clear? So fine. So a dot class is there. I'll decompile now. See this. Open with j. Sorry. You can use your decompiler. Public abstract. Did I write this there? Have I written it here? No. But it has been added. So even if you don't write, by default it will be added. So if you write also, no issues. This is optional, but generally we don't write because by default it will be. This is also not a problem. It will still compile. If you are not writing, it will be added. Are you clear with this? Okay. So see, for M1 I'll write like this. For M2 I'll not write it. If you want to see that, void M2. One more method is there. I'll compile. Again a new dot class is generated. Go and check. Close this. See, now again a new dot class is generated now. I'll say open with j. See, for both it has been added here. Understood? And for here I have added it only for M1. So in the source file, if you don't write also, in the dot class it will be added by the compiler. If you don't write public and abstract from methods in the source file, it will be added by the compiler in the dot class file. Similarly, see this, int x is equal to, I will only declare the variable. Will it compile? It will not compile. See this. What is telling? Give the value. Why? Because it is public static final variable. You cannot have a blank variable in interface. Final blank variables are possible in class, subclass, abstract class, but you cannot have final blank variables in interface. Why? Because see, if you make it as blank, you should initialize it where? If you have got a final static variable, it can be initialized only in two locations. One is hard coding, other is static block. Final static variables can be initialized only in two places. One is hard coding, second one is in static block. But an interface cannot have what? Static block. Because of that, it will not allow you to compile only. It says give the value there itself. And say I have to give the value. So you cannot have a blank final variable in an interface. Understood? You cannot have a blank final variable in an interface. It's mandatory you have to give the value. So when you are declaring it, give it. Now once I give it, it compiles. Once it is compiled, let's go and see now. What is there in the dot class? C dot class. Open with j. Did I write public static final for x? It has got added now. So since it is final and static, so if it is a static final variable, you have to initialize it where? Either in hard coding or in static block. So since an interface cannot have a static block, you have to initialize it while declaring only. And if you don't initialize, compiler starts giving you error. Are you clear this? Okay, so this is how it happens. So anyway, these are only two possible members now. You don't have to worry too much about all this now. Okay, an interface can contain only two members. Okay, it can contain a static final variable, public static final variable, and it can contain abstract methods. But we'll start seeing more deeper into this. But right now, in the first example, I will not be taking variables. I will be taking only abstract methods. Are you clear with this? In the first example, I will not be taking I showed you how to write an interface. Understood? So this is how you write an interface. So next. So you have to write now class interface. Let me try to use this now. Which one? The interface data type. Public static void main. Yeah, see, if you want I can print hello world. A perfect program. I'm still not using that interface. Yeah, hello world is getting executed. Your main program is getting executed. I can declare a reference variable of type what? Interface. This is possible. So what is this? Declaring a reference variable of interface type. Correct? Yes or no? You are declaring a reference variable. Fine. So yes, it compiles. See, it does not give me any error. But let me try to create an object of this. It will not allow because it's abstract. Why it is abstract? It is unclear. Here it is abstract means unclear it is. So you cannot bring unclear things into existence. Okay, practically you cannot bring unclear things into existence. In Java, bringing things into existence is called as creating object. In Java, bringing things into, what is an object? Bringing some code into existence. So you cannot bring an interface into existence, or you cannot create an object of an interface. That's the meaning. You cannot create an object. See, by chance, you might ask me why. Supposingly an object of interface gets created, supposingly. Okay, and if this code has come into existence, what will M1 and M2 execute now? You're following the problem now? Supposingly your interface object has got created like this. I'll say A is equal to new A. So when the object has got created, if I call A.M1, what will M1 execute? There is no implementation only. If I call A.M2, what will it execute? Nothing it can execute. So that's why there is no use of creating an object of an interface, or in other words, you cannot bring unclear things into existence. Simple as this. You cannot bring unclear things into existence. Okay. In simple words, what we say is in Java, we cannot create an object of interface. Just explain you why you cannot create an object of interface. But simple statement of Java is what? You cannot create an object of interface. That's it. So what to do now? You have to put the implementation for it now. You have to give the implementation for those two abstract methods. So how will you give the implementation for these two abstract methods now? That's the next question. So for that, we use one data type called as class. So we'll be using the class data type to complete the implementation for the interface. So interfaces set the standard for the classes to complete the implementation. Are you following now? Interface always sets the standard for the class to complete the implementation. So it's the duty of the class to complete the implementation now. So that is the reason I'm using the class data type to do the implementation. Are you following now? That's the reason I'm using the class data type to complete the implementation. So what I'll do, I'll write class. Okay, I'll write B implements. You can use, see, while writing it on the board, I used AZ, no problem. Here I have used some other names, no problem. Implements A. So class B is implementing A now. So void M1. Just a second, the project will switch on. So class B goes on to do the implementation for now interfacing. See, it is implementing. Class B implements A. So implementing means what? It has to complete the implementation. But the keyword used is what? Implements. The two new keywords what we are seeing now. One is interface and the other one is implements. So two more keywords. So again you have to do the implementation for what? See, I'll try to compile now. Let us see what is there. I am giving the body for only one method. Let's see what happens. It says B is not abstract. Means you have not done full implementation. You have not done full implementation. You have done partial implementation. Okay, you have done partial implementation. If you want to do partial implementation, means if you are not interested in doing full implementation, then make the class as abstract class. If you want to do full implementation, then do it. Two options it will give you. So fine, you have to do the implementation. So I will give the body for what? Void M1 and void M2. So many errors you will get. Just see how you resolve that. So inside M2. So those things are, again I will compile, but I get one more error. It is attempting to assign weaker access. You have to mandatory make the methods as what? Public. This is also public. Here also you should make what? Public. So actually if you see technically, the class is implementing the interface, yes. But if you see again, it is overriding the methods. So a class implementing the interface has to override all the methods of the interface. A class implementing an interface has to override all the methods, abstract methods of the compulsory it is. It has to override all the abstract methods of the interface. Are you clear this? So let's see this now. So I cannot create an object of A. Fine, let's see this now. But definitely see this. Z is equal to null. I can declare a reference variable. Now what will I do? Z is equal to new Z. I can create an object of Z. This is possible. I can call the method z.m1 valid. Okay. Sorry, I've used B now. B b.m1, b.m2. Now perfectly it will work. See this. It is executing both the methods. If I want, I can say A is equal to B also. This is valid. This is valid. So once it is valid, I can call A dot M1. Also I can call A dot M2 also. With A also I can call and B also I can call. Are you clear with this? So both the methods are getting executed. But I am executing these two methods from two variables, using two variables. One is with A, other one is with Z. See here the two methods are called it with B variable. Here the same two methods are called it with A variable. Understood? So you can invoke the two methods M1 and M2 either with A variable or B variable. Are you clear? So now what happens is, see, a class which is implementing an interface, understood, has to override all the methods of the interface. It has to compulsory. And while overriding, it should make it as public. Why? You know the rule. In the method, if the superclass method is having one access, in the subclass you should have a equal or higher access. In the superclass, what is the type of access now? Public access. So when you override compulsory, it should be equal or higher. So I'm going with public itself. That's it. Are you clear? Okay. Next, one more thing. See this. Sometimes you will not. Okay. I think this is sufficient. Okay, fine. Clear this? So this is how you write an interface, and you use an interface in this way. How do you use an interface? What are the steps to use an interface? Writing is one part, but using an interface, how will you do? You have to write one more class which implements it, override all the abstract methods of the interface, then create object of the class implementing the interface, and then call the methods. This is how it will happen. Are you clear? Any questions here?
Can we have extra members in class?
Okay. So now let's start saying more examples on which are now interface. Okay, one of the question would be, yes sir, can I have extra members? You can have extra members. Where? In class B. It's not mandatory that you should override only those methods. If you want, you can have extra methods also in class B. Like example, M3. Now class implementing an interface should mandatory override what? All the methods. Compulsory, that is there. But while if you want, you can have extra, that is optional. M3 method is optional. Okay, so next, see, but if I have that extra method, I can call it only with what? B dot M3, but I cannot call it with A dot M3, that you know. Okay, and one more thing, when you are writing M3 method, you can give your own type of access. For M3 you can give your own access, you can make it as private, protected, default or public. You know, I have not used it right now, but if you are interested, you can have any access specifier for M3. But compulsory when you are overriding M1 and M2, they should be public, but this can have any type of access. You know, access specifier is the next topic I'll be covering, don't worry about this. So here M3 is not public now. If you want, make it as public, or if you want, leave it. See, if B dot M3 I'm calling, it will execute. But M3 will not be supported in what? Dynamic polymorphism. M3 will not be supported, it is not overriding, M3 is not overridden. So it will not be supported in dynamic polymorphism. But definitely say, M3 can be made as public, or you can have it without public. That's your wish. Clear? Okay. Some more will start seeing now. So a class implementing an interface can have extra methods also. Mandatory, it has to override all the abstract methods. Plus extra methods if needed, it can be added. Okay. So more things we'll see now. Sometimes there will be scenarios now. So you'll be having an interface. Interface A will be there. Void M1, void M2 is there, void M3 is there. One more example I am taking now. Void M1, void M2, void M3. Three abstract methods are there. There are three abstract methods. Now class B will implement, you know the rule now. What is the rule? It has to compulsory override all the abstract method. Compulsory it has to override. Plus extra methods it can have. That is optional. But B decides to override only two methods. And you have to make it public. That is mandatory. By chance if I miss also while writing public, you better write it off. When a class is implementing an interface, sometimes I'll forget it. But you have to compulsory override with public. Understood? Public void M2 SOP inside B M2. So these are the two methods. Extra method also I'll write void fun SOP inside fun now. So class B actually when it was trying to implement this interface, it wanted to actually do partial implementation. Sometimes there will be scenario. See, this is completely open for implementation. Interface is completely open for implementation. So class B decided to complete the implementation, but not fully, partially. Class B decided to complete the implementation partially. So that is why class B is not doing complete implementation. No, it becomes what? Partial implementation. If it is partial implementation, then obviously this class has to be made as abstract. Now you cannot create an object of abstract class also. This is possible. Now writing extra method is optional. I am not telling mandatory write it. If you want write, else leave it. Okay. But here if you are observing, class B decided to do partial implementation. Class B decided to do partial implementation. So now I want to complete the implementation. What are the options you will take now? What will I do next? I cannot create an object of A also. I cannot create object of B also. So write what? Class, you'll write subclass. What will be the subclass name now? Class C. What will you do now? Extends B. Why always this story you will take? Okay. See, the story is here like this. A, B, they are related like this. Okay. In fact, when we implement the relationship, we do not show it with straight arrow mark. Generally, we do not show the relationship with straight arrow mark. The relationships we do not show it with straight arrow mark, we show it with dotted lines. That is the UML diagram. We'll see it. Understood? So see, A extends B. This actually in UML diagrams, we'll understand that later. This represents straight arrow mark represents extends. This one represents implements. But both are used for doing what? Is a relation only. This is implements and this is extends. Fine. So what is happening here? This is A, this is B. So now you are telling me class C, let it extend B. You are telling let class C extend B. They are telling let class C extend B. But why? If you extend B, what will happen? Remember, you will get the features of B into C. Correct. What you are telling is correct. But before you do it, you should think whether class C extends B or class C implements A. That is also possible. Understood? So you should know what to do. Always simply don't blindly follow. Sometimes if you want these two things, which are M1 and M2 of class B and fun, then you go to say class C extends B. If you want M1 of and M2, M1 and M2 of class B plus fun of class B, then you go for class C extending B now. Okay. Otherwise, you can say class C implements A and do the complete implementation. So it's up to you how to do the implementation. But right now I'll be using the track of what? Class C extends B. Otherwise, it would have been like what? Class C also could have implemented. You understood now the difference, sir? Class C could have implemented A. Understood? Or class C can decide to extend B. If you extend B, what will happen? You'll get the features of B into C. This logic, M1 logic, M2 logic and fun logic will get into C. Sometimes you'll not be interested in that logic. That time what you can do? Class C implements A you can do again. That is also possible. Understood? So let's find, you'll understand when to do what, you'll understand later. Okay, but just I'm following the route of what now? Class C is extending B. These are the both options. But I am taking which option now? This option. This option we'll see later. Which one? Class C implementing A we'll see next. But right now I'm taking the approach of class C extending B. So now class C decides, shall I clear all this now? You understood the arrow mark? Arrow mark is used for showing what? Implements. A straight line indicates what? Extends. So this is extends. Again, if class C implements A, this becomes implements. Are you understanding now? Implements, extends, you should understand this. Fine. Now class C decides to extend B. Now class C, when it is decided to extend B, compulsory it has to override what? M3 method. Compulsory. Not all. What you don't want you override, but mandatory you have to override abstract method. Which methods you don't want you override now? Which an M1 also you can override, M2 also you can override, fun also you can override. But mandatory it has to override M3. Understood? So we'll go on with overriding with what? M3 now. So but again it should be what? Public void M3. SOP inside M3. Following. So again if you want you can add an extra method. That extra method can have its own name. What name you can give? I'll give the method name as test. Any name you want to give. Void test. SOP inside. This extra method is optional. I'm not telling mandatory. Understood? All these extra methods are optional. If you want you can write. See this. See A is equal to null. I cannot create an object of A. Correct. I can declare a variable. Similarly, I cannot create an object of B. Why? Because it's also abstract class. So this is an interface. See, we are using 3 data types here. Carefully observe. Or 4 data types. We are using, sorry, 3 data types. 3 data types. One is interface data type. One is abstract class data type. One more is subclass data type. We are using 3 data types. One is interface. Second one is abstract class. Third one is subclass. Now when do you use an interface? When you want to keep it open for implementation. When you do not want to do any implementation. When do you use an abstract class? When you want to do partial implementation. When do you use a subclass? When you want to add or change implementations. You know the answers now. So start seeing it technically. Rather than I'm overriding and doing all this. When I use a data type, you should start thinking now. Okay, I'm using this data type for those reasons. Understood now? So that's how you should start thinking now, because we are almost all completing all the data types now. So whenever I write any data type, it should strike to you now why I am using that particular data type. Are you clear with all these 3? Fine. But I cannot create an object of an interface also. I cannot create an object of abstract class also. But definitely I can create an object of subclass because it is concrete. So only which are clear and concrete you can create the objects. So what will I do now? C is equal to new C. Means you can create an object of C and refer it with any variable. A also can refer to C object, B also can refer to C object, C also can refer to C object. All the 3 variables can refer to C object. But initially I am using C variable to refer to C object initially. So the object of C gets created. What are the members of C now? M1, M2, M3 methods of which one? interface A. Then from abstract class B you are having M1 and M2 and fun method, concrete method. Then from C you are having M3 and test. Same story, you know, no, there is no difference. But these are abstract methods, M1 and M2, M3. M1 and M2 are overridden, M3 has been overridden here. So when the C object is created, okay, when the C object is created, I can call the methods. Which method? All the methods I can call from C. Which one? The rule continues. What members can be accessed from the object depends on the type of reference variable. Which member gets access depends on the type of object. Still it is going to continue. C dot M1. Understood? C dot M2, C dot M3, C dot fun, C dot test, all will get executed. Similarly, I can say B is equal to C. I can give the value of C object to B variable. I can call only how many methods? M1, M2, M3, fun, but not test. Test is error. This is error. You cannot call this. Understood? Similarly, I can say A is equal to C also. But with A I can call only how many methods? 3 methods. A dot M1, M2, M3. I cannot call A dot fun and A dot test. These are errors. You cannot call these 2 methods. Why? A superclass variable can refer to subclass object. What members can be accessed on the object depends on the type of reference variable. Same rule, but criteria for overriding is object. Still continues. Understood now? So you can access these members like this. So here in this example what you are understanding now is, like at least we are getting the faint idea, like faint idea, I'm not saying complete idea. A faint idea like when you use an interface, when you use an abstract class, when you use a subclass. Understood? In the previous example I had used 2 data types. Which are there? Interface and class. I had used class there because I wanted to do concrete implementation. In the previous example I had used, what was the relation I had used? Interface A was there and class B was there. Now class B was what? A concrete class. Understood? Class B is a concrete implementation. So I used class. See, no implementation interface, a complete implementation class. Okay, no implementation interface, partial implementation abstract class, adding or changing implementation subclass. See how we are rotating around the data types now. When to use class, when to use subclass, when to use abstract class, when to use interface. Following now? So we'll start using them extensively. We'll follow it all, no problem. Shall I clear all this now? And I believe you can code and see the output of this. Understood? Fine. Or you want me to show this, sir? It's very simple. Okay, or I'll show it, modify and show it in that example itself, and we'll finish it off. Let's take the same example now. I'll just modify it off here itself. Void M1, void M2, void M3. It's better you write another example. Understood? So now class B decided to implement what? Only which method? 2 methods. Inside B, and done. So now what happens? Class B is implementing A. But it should have completed all the implementations. Since it is not done, I'll try to compile. Gives error. B is not abstract. Either you complete the implementation or make the class as abstract. So once I make this class as abstract, obviously I cannot create an object of which one? B class. So all this will go wrong here. So we'll comment off all this. Done now? So now abstract, you cannot create an object of B. If you want, you try it. B is equal to, I'll clear off all this. This is error. B is equal to new B. This is also error because B is abstract. So what should I do now? Class C extends B. Mandatory or to override what? So you can write on extra method, that's optional. I'll write void test. It will not take that into consideration. Writing an extra method is okay, but mandatory you have to still override this M3. So I am compiling, it gives me error. C is not abstract, it does not override. Okay, either you make C as abstract or give the body for M3. So I decide to do what? Give the body for M3. So now I can write inside M2 or inside CM3. So it is complete now. Again you can compile. B is equal to new B. Sorry, you cannot create an object. Sorry, these all errors you remove now. Again you compile, still error is there. One more, weaker privilege. Which one? M3 should be made as public. So fine. Now I can create. See, I cannot create an object of A. I cannot create an object of B. But definitely I can say what? C is equal to null. This is okay. I'll say what? C is equal to new C. Yes, once I create the object of C, C dot M1, I can call all the methods. C dot M1, C dot M2, C dot M3, C dot fun, C dot test. All methods can be executed with help of C variable. All the methods, see there. M1, M2, M3, fun, test. If you want the same reference, I can give to what? B is equal to C. With B I can call how many methods? B dot M1, B dot M2, B dot M3, B dot fun. I can call these many. But B dot test is error. Correct? Huh? So I'll compile error. You cannot access. See, what members you can access from the object depends on the type of reference variable. So this give me error. So, but if I comment that, yes, all methods will get executed. So from B you can see I have called M1, M2, M3 and fun. But if I want, I can call which one? A is equal to C also. And with way I can call what? A dot M1, A dot M2. So remember, this is very crucial now. This will get into, if you understand this, your future level of programming becomes very easy, because we'll be working with all the data types. So when you are working with which data type, you should know which members you can call now. So these both will be errors, which are fun and test. Otherwise with A I can access what? All the methods. Finally now, one more thing, the final formula what we are deriving. A is equal to new, C is also valid, correct? Or B is equal to new, C is also valid. Understood? So this is how they get related. B is already defined. Okay, means change the variable name. A1 is equal to new C, B1 is equal to new C, because I already declared A and B there. Change the variable name. But I created objects. I am not using it. Clear? So this is how the things are getting executed. Now sometimes there will be a requirement. I will comment this here. Now the requirement will be, I am not writing class C now. My requirement is very simple. Okay, my requirement would be what? I do not see, I want interface A is there. I want to do a concrete implementation for only M1 and M2. Concrete implementation. My intention is not to do partial implementation. My intention is not to do partial implementation. I want to do the concrete implementation for M1 and M2. And I do not want to give the body for which one? M3 at all. I am not interested in doing what? Partial implementation. I don't want to do partial implementation. I want to do concrete. But I am not interested in giving the body for what? M3 at all. So that is when what we do, you can write M3 method here and deceive the compiler. You understanding now what is deceiving the compiler? What was your reason? See, earlier why was this an abstract class? Because I wanted to do partial implementation. But now my scenario is what? I want to do concrete implementation. Okay, but I am not interested in giving the body for M3. So I have given the body for M1 and M2, but I am not giving the body for what? M3. Correct, valid, it will compile now. Yes or no, it will compile. Now I can create an object of what? B. And which methods I can call? All the methods you can call. But M3 it will not execute anything. So I can create an object of what now? B now. You understanding what I am trying to say? You can say B is equal to new B. B dot M1, yes, it will execute. B dot M2, it will execute that also. B dot M3, now which M3? If you want, you can say B dot fun also, that is secondary. Okay, but M3 is getting executed, but nothing, no logic inside that. But which data type did I use now? Class data type. So you should know when to use an interface, when to use a class, when to use an abstract class, when to use subclass. Here which data type I am using now? Class data type. Classes are used for doing what? Concrete implementations. Clearly you will understand that meaning, concrete. Still I have to explain you difference between all the 4 data types. Are you clear with this? Classes are used for doing concrete implementations. Abstract classes are used for doing partial implementations. Subclasses are used for doing adding or changing implementation. Very simple. Interface is open for implementation and does not contain any implementation. But it sets the standards for subclasses to complete the implementation. Clear? Okay. So this much you have understood. Now we'll see one more example with variables. We'll see one more example with variables now. So class interface variable demo. Sorry, use an interface. See, in text you have to initialize there itself. Yes or no? Otherwise you get what? Error. If you don't initialize, I have shown you already. See, I am just declaring it. It's a blank final variable. Error equal to expected. So you have to give the value is equal to 5. But for class, subclass and all, it will not force you to give the value. When you are declaring variables in class, subclass and all, it will not force you to give the value because they are static or instance variables. They are not final variables. Understood the difference now? They are in a class. What will you have? You will have a static variable or instance variable. If you are interested, you will make them as final. But in interface, you cannot have what? Instance variable also, static variable. You will have only final static variables. So that's why it will force you to do the initialization. Fine. Now fine. Then this is done. I can have one method called as M1 also. I'll have one method called as void M2 also. I'll do one thing. I'll have 2 variables here. Int y is equal to 6. Just I'm going with 2 variables. Now you can see these are public static final. I'll compile. A dot class is generated, and if you want, you can go and see in the decompiler. If you want, you can go and see with the decompiler. 1 second. I've closed it, I think. You can see a public static final has been added. Did I write there? No. So fine. If they are now, if they are static variables, see I can access them with what? I don't have to create the object. I can directly say with the interface name only I can access. Value of x is what? Plus a dot x. Valid now? Plus a dot y. See this? Give me the output. So I didn't change this y. 5 and 6. I can access it with the interface name only. Okay. So or you can do it like this also. What? You can declare a variable a is equal to null, and you can access it with what? Reference. See here I have accessed with interface name. A dot x is interface name. Here I will access it with what? Variable name also. Possible. You can access the static final variables of accessing now. How do you work with it? So with the interface name or with the variable name also possible. See, it is printing means don't see output. See how I am accessing the value. Are you following? And now one more thing. Supposingly a class implements an interface. Now very interesting. Class B implements A. So you have to compulsory override what? Now you have to decide. You want to do full implementation, use a class. You want to do partial implementation, use abstract class. Very simple now. So void M1. But it should be what? Public. Here in this example, concentrate on variables more than methods. So I can access those variables even in what? In the class also I can access the variable. Check out. But how will you access here? Directly. Understood? So and if you want, I can access these values directly in the class which is implementing the interface. Means any class which implements the interface, will inherit all the variables. Any class which implements the interface will inherit all the variables present in the interface. That's what I am trying to show you. See here how I am accessing directly now. Understood? It's not only there, in M2 method also I can access. That's your wish. Void M2, there also you can access. Anyway, you can access it in M1, why can't you access it in M2 now? Yes or no? Inside M2 you can see the value. Now see this. I will comment all this. See what all ways we can work, you see now. I will create an object of which one? New B. Now I can refer it with what? Either A or B. That's my wish. So I will refer it with which object? A only I will refer. Or I will refer it with B object. B object. BB is equal to new B I will tell. So now see, B dot, I will do one thing. Now after creating the object, I can access those values with what? B also. Carefully see, value of X with B is what? B dot X with B dot Y. See this also you can access this way also. Done? See now, I am still not called the methods. I am accessing it with B dot X, B dot Y. See here. Okay, semicolon. What is that? Okay, it compiles. See now I am accessing the values with what? B. So means, see I can create object also and access. Understood? I can create the object also and access with B. Class is implementing it. Or let us check this out. BB is equal to null. This way also you can access. Or B class dot X also you can access. See what all way you can access. B dot X with the interface name. Right now I showed you with B reference variable name. Now I am showing you with B class name. See what always? Correct? Huh? With B reference variable, with B interface. Now I'll show you by calling them with methods also. See they are available in B class also. B dot M1, B dot M2. Everywhere you can access. These many places you can access them. Null pointer exception. Okay, create the object. Yeah, create the object. Now see in M1, M2 also you can call them. Where and all you can access them. They are static final variables. So got it now, where and all you can access? One I can access it directly with the interface name. A dot X, A dot Y. Or I can go with the reference variable name. A dot X, A dot Y. Now once a class implements an interface, I can go with the class name dot variable name. B dot X, B dot Y. Or I can have a reference variable of the class implementing the interface like BB. It's a reference variable. Small b dot X, small b dot Y also I can access. Or I can create an object also of B and access. BB is equal to new B, B dot X, B dot Y. Or I can also access them in the class implementing the interface. These are all the possible locations. Are you clear with how you work with the variables here? And they are static and final. You can't modify it. See this now. This gives me error. B dot, or I'll try with A dot X is equal to 99. Till now everything was working. They are static final variables. You can't change the value of them. Clear this? You cannot change the value of what? A dot y is equal to 88. This also you can't change. So they are static final variables, you can't change. Do not try to change the value either with A or with what? B. You try to do anything, you can't change the value anywhere because there is only one copy. There is only one copy and you cannot modify the value. All the 4 errors you are getting. Clear? Fine. Now next example we will see. What are the different members? I will comment of everything here. See, from top to bottom I will comment. I will just keep my interface open now and I will work with the interface. Okay, everything is commented. So now see, let us see what are all the possible members of an interface now. So these two it will compile. See now the next example what I am showing is, your interface can contain what? Only 2 possible members. What are they? Public static final variables and abstract methods. That's it. It cannot contain what? Instance variables first. So let's see, int p. See, you are thinking it is an instance variable, but compiler will convert into what? Public static final variable. So you can't write. You can't write on static variable also, because if you write static also, what will happen? It final will be added to it. Final will be added what? Implicitly. It is asking the value. Okay. So static variables and instance variables ruled out in an interface. Clear? Next, let's see. Can I add a block? Let's try with what? I commented everything. Just see, I am working only with the interface. I am trying to add one block now. There is nothing else in this program. We are all seeing only the possible members of an interface. Let's see, inside static block. Let me try to compile. No. Will not allow you. I have commented everything now. Yes, sir. So, one second. I'll just remove this and compile. See, it will compile. It is compiling. But once I add the static block, anything wrong in the block? Nothing wrong now. Leave all this, man. You don't worry about all this. Just see only that now. Is it possible to compile? No, it says some error. Okay, but shall I remove this? It will compile. So that clearly shows an interface cannot have what? Static block. Fine. I'll try to have an instance block. This is instance block now. You cannot. Compiler will give you error. It will not allow you. Okay. I'll try to write a constructor. I'm trying to write what? Constructor. This also is not possible. Okay. Then I'll try to write one concrete method. Void M2. It's concrete now. This also is not allowed. Okay. I'll try to write a static concrete method. This also is not allowed. So all your members are not allowed here. So very simple data type now. In class we struggle to learn what? So many members, but in interface what? Only 2 members. So very simple data type it is. But very rich and powerful. The minimum duration taken to understand what an interface is, can you guess? Let's see. Understood. So this is how an interface can be designed. And one more thing, can I have a concrete method? Now what is that I want to say? Yeah. See, M1 is abstract method now. Can I make it as static? You know very well, static methods cannot be made as abstract. Static methods compulsory should have what? Body. So this also compiler will give error. You cannot make your... Why can't you make abstract methods as static? Because you can access them without creating an object now. What will it execute? There is no body only for it. Understood? There is no body only for it. That's why you cannot make abstract methods as... abstract methods as static. Clear? So all this you understand. So an interface can contain only what now? 2 members, public static final variables and public abstract methods. Done. So more things we'll see now. So I have to tell you now, interface, okay. So the abstract methods of an interface can contain what? The abstract methods of an interface can contain even parameters and return type. The abstract methods of an interface can contain parameters and return type. Let's see that now. Example. So supposingly there is an interface A. Now it is having one method int add, int x, int y, valid code, int multiply. Don't think it should always have return type as void and no parameter. This is all possible. So when you override now, you should compulsory write the logic for this. So class B, when it implements, what it should do? Override the two methods. Yes or no? Again, I have chosen a class. Means what I want to do? Concrete implementation, full implementation. So how will I do it? Int add, int x, int y. See now here it becomes more clearer. Int z, z is equal to x plus y. Return z. Yes or no? Extra members you want to add. Int multiply. And here you start understanding abstraction. Int z, z is equal to x plus y. Perfect. We have seen M1 and M2. Now see. Supposingly, I wanted to add two numbers. I wanted to multiply two numbers. And I was not interested to write the logic. So what will I do? I will set the standards for you people to complete the implementation. Understood? So what will you do now? You will write class Z, implements A. Yes? Now what will I do? I will create an object of your class. And I will use your code. See how it will work now? You understanding what is abstraction here? PSVM, see this. A is equal to null. A is equal to new B. Valid code. Whose object is created? Your object. Nice NUBC interface I wrote. And I set the standard for you to complete the implementation. You have completed the implementation here. I'm not saying no. And I'll use your work with your code now. How will I work? Using superclass to subclass object. I'll not even look into the method names of your class. Why should I look into the method names of your class? Because I know Java is very rich in what? Dynamic polymorphism. Okay. So, and when you are also writing the logic, you are forced to use which method name? These method names only. You are so forced to override, add and multiply only. You are not going to write M1 and M2 there. Okay. So there's one thing what we say. Interfaces always state what they do. Interface always state what they do, but not how to do. So this interface is telling what? You write in for this method, you write the logic for adding two numbers and returning the result of this. For this method, what is the meaning of this method now? You write the logic for multiplying two numbers and having return the result of it. So interface always state what they do. It's only telling you what to do. Means I have written this interface. I have written this interface and I'm telling you what to do. But I'm not telling how to do. So you'll write the logic now. How are you doing it? See, this is the way you are doing it. You can write this logic in 1 line or 10 lines. I'm not bothered. So this is the most important thing now. There are many points which come out in an interface now. Interfaces are open for implementation. Understood? Interfaces do not complete any implementation. Interfaces set the standard for classes to do the implementation. Then interfaces always state what they do but not how it is done. They do not, means they only state what to do. Means what has to be done, it will tell that. Not how it is done. So you are doing it. Correct? So supposingly in add method you return minus value, what will happen? It is wrong logic. I will not use your class. I will not use your class. So you are forced to do what? Additionally means interface state always what they do but not how it is done. So once you have implemented, say I am using your class now. Once I will create the object, I will call the method a.add and I will send 10 and 2. I will get the result int r or int sum I will take. Correct now? I am working with whose object now? Your object. On what grounds? Superclass variable can refer to subclass object. Similarly, I will call which method? A dot multiply 5 and 6. So int result. I am very easily working with your object. I am working with your object now. I don't know how you have written the code, but still I am working with your code. So what is this now? Abstraction. Interface is helping me in achieving what? Abstraction. Getting it? So it is it itself is an unclear data type, but it is helping you to achieve what? Abstraction. I can work with your code now. Now to what level abstraction we'll see more. See, supposingly one person wrote this class. Now another person can write another class. See, class C, because I have set the standard. When I set the standard, many people can implement the interface. Understood? When somebody means I means when somebody sets the standard, okay, many people will be implementing now, not one. Okay, so and what will happen now? They will write. See, one more person, he will write the logic like this. I told you, interfaces always state what they do, but not how it is done. Clearly notice now. So this guy will write the logic in only one line. Valid now. Return x plus 5. See here, this guy wrote it in 3 lines. He declared one variable. He added, he stored the result in one variable called as z. Then he is returning z. Instead of that, what you do? Directly say what? Return x plus 5. You directly do the sum and return the value. So I can write int multiply, int x, int y, return what? X into y. So interfaces state always what they do, but not how it is done. You got the point now? So now what happens? Everybody is implementing. Now who implements best? I can choose it tomorrow, no? First I liked B class. Then later on I found out he is writing too much of logic. I want to have better performance. What will I do? Dynamic polymorphism. I'll remove that object, change it to C now. What happens? Now whose object is created? Somebody's object. And I'm working with his code. I only set the standard. Make others implement. Understood? And whose code I like, I can start using it now. Understood? So this is how an interface will be used in programming. So somebody sets the standard, somebody will implement it. And then we can start using it like this. So whose object you want, you create. And here the great support of this is dynamic polymorphism. So we can achieve very high level of abstraction here. We can achieve very high level of abstraction. So interface is an abstract data type, but it provides very high level of abstraction. See here, the meaning of that. New C means the code is executed from C object. New B means the code is executed from B object. Abstraction. What code they have written, we are not bothered. We are getting our result there. So it's unclear for us how we are getting the output. But we are getting the output. That's what is abstraction. It's unclear how you are getting the output. Okay, but the data type itself is abstract. Means what? It's unclear. Understood? So this is an abstract data type used for implementing what? Abstraction. Not only that, an interface can be used for what? Implementing all the properties of OOPs. We can do encapsulation. Interface is doing what here? It is encapsulating 2 methods. Okay, it can also be used for what? Polymorphism. It can also be used for inheritance. It can also be used for what? Abstraction. Abstraction I told you. Other 3 I'll explain. Interface supports all the OOPs data type, all the OOPs features. And interface also supports you to implement encapsulation, polymorphism, abstraction and inheritance. We have only covered the abstraction part of interface. And encapsulation you can see. It's encapsulating 2 methods now. That itself is encapsulation. Abstraction and encapsulation we have covered. If you want, you can see it supports polymorphism also. If you want, it supports inheritance also. I'll show you next. Interfaces support everything. Clear? So there are 4 data types provided by Java to implement OOPs. Clear with this now? You are understanding what is dynamic polymorphism now? So interface always state what they do, not how it is done. Next. See, now you might be having one more thinking. What is the use of abstract method? Okay. See, abstract methods are generally used for decoupling, declaration and implementation of a method. These are the words you have to use in interview. Abstract methods are used for what? Decoupling, declaration and implementation of a method. Okay, what do you mean by declaration and implementation of a method? See, this is what is declaration and, see, in a class what happens? Void M1. See, this is class hello. You are declaring the method here itself and implementing the method here itself. Yes or no? In a class, in a concrete method, what happens? Declaration and implementation of the method happens in the same place. But in an interface, what happens? Declaration happens on one place. Implementation happens in another place. Understood? So abstract methods help you in decoupling what? Remember the point. Abstract methods help you in decoupling, declaration and implementation of methods, and they help in setting standards. They help in setting standards for other classes to implement it. Powerful, they are very powerful. In fact, you neglect them, abstract methods. They are very powerful methods. Okay, they set the standard. Okay, are you clear with this? So concrete methods, in concrete methods, the declaration and implementation is tightly coupled, but in an abstract method, the declaration and Implementation is loosely coupled. You are separating them. You'll write, do the declaration here. Implementation is done here also now. Check out now in the for abstract method. Declaration is done here. Implementation is done here. Again implementation is done here. Two places implementation has been done. Which implementation you want to use? Decide. Based on that you create the object. You say new B, you are working with B object. You say new C, you are working with C object. So you can decouple declaration and implementation. You understand what's decoupling declaration and implementation? So these are all very crucial points when you start programming, because you should know how to write your logics. Writing logic is not big thing. Okay. So you have to decide upon all this. When will you do concrete implementation? When will you do partial implementation? Okay, when will you set the standards? All that you'll understand. Slowly, see, these are only introduction. When I start writing examples, more examples, you'll understand all this. So I think you can code this now. So what is the concept you have covered here? There are many concepts in this example. What are the concepts? Abstract method can have parameters and return type. Okay. So now that is one thing we saw. Another concept what we saw is interfaces always state what they do, but not how it is done. It is only telling what it has to do, but not how it is done. Then we are seeing dynamic polymorphism concept. Then we are actually understanding what is the advantage of abstract methods. They help you in decoupling, declaration and implementation. Many points we are seeing in one example. So always from an example you have to understand concepts, not output. Thousands of examples you will be seeing across the books. Or even my examples. Might be I have covered 4 points. More points if you want you can add. Understood? So see examples technically rather than as output. Any questions in this? Okay. Now by chance, just I am adding it. Just making you understand. If I have one static variable here. Now phi is available to what? B also, C also. If you are having one variable, it will be available to all the classes implementing that interface. That also you understand. And you know how to access it now? B.x possible, C.x also possible. By chance if I have, this is how it works. Because many people will be implementing the interface. But nobody can change the value. That's the greatness of it. B also can use it, C also can use. They can only use, but they cannot modify the value. And there is only one copy. Clear this? So see how brilliantly they have designed all this. So fine. This is how an interface is getting designed now. Fine. Shall I clear all this now? Okay. Now the next concept is an interface can extend another interface also. That's one more point now. An interface can extend what? You have seen class extending class. Understood? But an interface also can extend what? Interface means interface supports what? Inheritance. That's the concept. It's very simple. So interface we are saying extends now. Interface A is there. It is having void M1, void M2. So I have interface B. See now, there is one more person who wants to do no implementation. Example you take like that now. Simply don't see inheritance. Some interface is there. He wants to add some more extra abstract methods now. He wants to add some more extra abstract methods. But can he go and modify it in that interface? Because that data type has been written by someone. So he can't modify somebody's data type. So instead what he will do, he will say interface B extends what? A, valid code. It's highly valid. So you're using what? Interface extends, two keyword you're using. Extra members you add void M3, void M4. Now the person who is interested in implementing the interface, he can decide anything. Like he can say what? Class, see, Z decides to implement A means he will override how many methods? Only 2 methods. If he decides to implement A, he will give the body for only 2 methods, void M1 and void M2. But if class Z decides to implement B, he has to override 4 methods. Very simple. Okay, so I'll have void M3 now and void M4. You give the body, you know how to give the body now? Write the logic, that's it. Okay, write the logic. So this is how it happens. So now class demo PSVM Understood. Class Z implements B. I can create an object of Z. Yes or no? But I can never create object of what? A and B. So your wish. So when you create Z object, you can call all the methods. Z dot M1, Z dot M2, Z dot M3, Z dot M4. But very interesting is what? A is equal to null, A is equal to Z. With A I can call only what methods? M1 and M2. Correct only now. The person who wrote A interface is interested to work with what? Only two methods. So that's why using is variable. Understood? Next, B is equal to null. B is equal to Z. B is equal to Z. So with B I can call all members. Extra member if you have, you can't call. Understood? With B you cannot call extra member. But if it is there, anyway we are not having it now. So I can call all the four methods, M1, M2, M3, M4. Very simple now. So we are seeing in which one now? Inheritance. Clear? Clear this? Can you do this now? Okay. Next we'll see interfaces also support what? Polymorphism. Example, in this one I will take. Shall I modify here? See, M1 can be overloaded now. What is this now? Overloading. Understood? M1 is what? Overloaded. So when you implement now, you have tried two methods. If by chance if I implement, don't say B now. Don't see B interface. See only M1 now. M1 has been overloaded now. If class Z implements A, what it should do? It should override both the methods. One without parameter, one with parameter. Anyway, it is supporting what? Overloading also, it is supporting overriding also. You have seen that. It is supporting overloading also, it is supporting overriding. It is supporting dynamic polymorphism only. Understand? Are you clear? Okay. I think this is one brief introduction to what? Interface. But more things are there to work with an interface. Okay. But one last point I'll tell you. Okay, about an interface for today. You know, this many data types you have seen. Class you saw, subclass you saw, abstract class you saw. Correct now? But this data type, they didn't use such kind of a name. What kind of a name they used? Interface name they use. Why? Can you guess? It's very simple. As I told you, I'll write one I'll write one data type. Just assume I'm writing one data type. Now you will implement the code. Now I'll use my data type to work with your code. I'm using means you saw in the previous addition multiplication. Understood? In the previous one you saw if there is interface A. Shall I clear all this? One last thing about an interface now. See, supposingly if this is interface A and I have written this kind of logic, int add and int multiply. You will implement it. How will you write? Class B implements A and you will override. You know that. So now what will I do? I will work with your object. Yes or no? How will I work with your object? You know how to override. Now just now we saw this. Okay, so what will I do now? See, to work with your object, I will use my variable. Yes or no? But actually I am working with your complexity. I am working with your code means what? Complexity. You have written the complex logic. I am working with it. Okay, how will I work? A dot M1, A dot M2. So I am using A data type to work with the complexity of your code. Yes or no? Yes. See, the English meaning you understand. The English meaning of interface. Okay, what is an interface in English normally? You have got so many, see, you know, whenever there is some complexity, okay, to work with that complexity, they usually give an interface to work with that complexity. You know, phone is there, lot of complexity is there inside it, but to work with that complexity, they give a very comfortable screen. The screen is the interface to that phone. TV is there, lot of complexity is there, but they'll give an interface to work with the TV. So always to work with complexity, generally what they give is interface. That's the normal English meaning of an interface. Same meaning is getting applied here. To work with your complexity, I am using this data type. Understood? So that's how it gets the name, interface data type. So an interface can be used to work with anybody's object, means with your object. Understanding the concept now? You can use an interface to work with anybody's object, third party objects we say. Means with anybody's implementation. That is how it gets the name. Okay, you get the name because the reason is it's on data type which can be used to work with any complexity. It can be used to work with complexity. Are you following now? So since it's a data type which can be used to work with the complexity, it gets the name now. It gets the name because it is used to work with the complexity. We are using it as an interface to work with the complexity now. Understanding now? To work with the phone, use the interface. Similarly, to work with your object, what am I using? A. To work with your object, I am using A. But what is A? It's a data type. So they wanted to give a name, and the best name what they thought was interface. So that's how it gets the name. Understood? It's a big thing now, which we'll be seeing later. We'll understand it. So interface is always used as a to work with the complexity of somebody's object. Understood? So interface is having a lot of meaning, which we'll start seeing in the later classes. So this is one brief introduction. So some points are there, you can write it. See, interface. It is a user-defined data type which can be used for what? Implementing loops, correct? It does not contain any implementation. Sometimes developers need this. They do not want to do what? Any implementation. But still what? It is used for setting the standards for subclasses to do the implementation. Why you don't want to do any implementation? Because you want to set the standard for others to do the implementation. Yeah? Next. It contains only two members. I showed you this. Okay, means public static final variables and public abstract methods. It cannot contain what? Instance variable, static and instance block, concrete methods, constructor. Now, why you can't use all these members in an interface? Tomorrow I'll show you. You might have one question now. Interface is not allowing you these members, agreed. But why? Explain me technically if you ask. Tomorrow definitely I'll be explaining you why an interface does not allow you these members, but only these members. Definitely I'll be telling you tomorrow. Okay. Because they create something called as what? Diamond problem. What is diamond problem? I'll tell you. Because it's getting into multiple inheritance. Tomorrow I'll be explaining multiple inheritance. Now syntax. See, this is the syntax. How do you write an interface? What is the syntax now? Interface name you'll give. If you are having a variable, data type, variable name value. If you are having a method, return type, method name, parameter list. Done? Example for this interface allow variable, data type, variable name, value, method. Like this you'll write. That's the syntax. Next, interfaces cannot be instantiated. Yes or no? But we can declare the reference variable of the interface. Interfaces cannot be instantiated, but we can declare the reference variable of an interface. Next, each method in an interface is also implicitly public and abstract. It's public and abstract. Okay. One more point I have to write, I think. Okay, fine. I've written it. All variables in an interface are by default what? All methods are public and abstract. All variables are by default public static final variables and have to be initialized during declaration itself. Next point. When a class is implementing the interface, that class must override all the abstract method in the interface, otherwise class should be declared as abstract. Next. When a class is implementing interface, then all final static variables of the interface will be inherited into subclass. See, for all these points I gave you one example. Understood? So points we generate theoretically, but actually every point you have to understand with example only. Understood? Then only you will remember this concretely. And this is an example to implement an interface. So when a class is implementing an interface, what you should do? Override all the abstract methods. You saw the earlier interface now. So this is the one class which is implementing that interface. Are you clear? Next. See, these points still I have to give you examples. You can write it down. Tomorrow I'll be discussing more on these points. It supports multiple inheritance. Understood? An interface supports multiple inheritance. For this I have not given example. Again I have to give example only and explain. Okay, but just you can note it down. One class can implement many interface. One class can implement what? many interface. Like if you are having one many interface A, B, C, D, 4 interfaces are there. Now your class, I will be showing you in the next class. Class Z implements what? A comma, B comma, C comma, like this you can implement. And now A, B, C, D are not related here. Understood? They are different interfaces. Till now we saw 2 interfaces, A and B. A and B are related. That time I can either implement A or I can implement B. But here the scenario is what? These 2 are not related. A and B are not related. So that time what happens? You can implement, a class can implement many interfaces. So this will be seeing tomorrow. Okay. So one interface can extend any number of interfaces. Okay, we'll see that. Multiple instances is not supported with other data. We'll see that. Fine now. Now why do you use an interface? It is used for decoupling and declaration and implementation of methods. Next, it always specifies what a class must do but not how it has to be done. Next point. It supports dynamic polymorphism and that is why it provides what? Very high level of decoupling and abstraction. This point, very important point. Then, okay, just write these points. We'll be seeing it in the next class. Okay, it is used for loose coupling. We'll see it later. And it's a data type which can be used as an interface. Yeah, this is the point I was telling you. It's a data type which can be used as an interface to work with an object. It's a data type which can be used as an interface to work with an object. It is because of this feature, this data type gets the name interface. This is the most crucial point. How it gets the name. Understood? How it gets the name? This is how it gets. And it is used for establishing what? Is a relationship. We'll see it. It is used for doing realization. Clear? It is used for doing realization. We'll see that point. Okay. Lastly, now see this. This is a very important thing now. Supposingly there's a class and class. How do you relate a class and class? So class always extends class. See the relation between a class and class? This is the relationship between a class and class. A class will always extend a class. Now what is the relation between a interface and interface? What is the relation between interface and interface? Yes, again, interface can extend what? Interface extends interface. Means if you want here, I'll just, this is example. Class B extends A. This is how you write. Here also example. Interface B extends A. So you understood the relationship between class and class, interface and interface. Yes. But next, the relation between class and interface is very important. Don't get confused when you are writing code. The relationship between class and interface now. Okay, how it happens? See, a class implements interface. Remember that. An example. Class A implements, class B, anything you can take, class Z implements A, that's your wish. But remember, all these are correct. Let's see this here now, class and interface. But an interface cannot do anything with a class. Means interface A, neither can it say extends interface Z, neither can it extend class called as A, nor can it implement a class called as A. Both is wrong. See, understand, class implements interface correct, but interface on the left hand side, nothing it can do. Are you clear this relationship now? Why, if you question me? Very simple. See here, if interface Z extends A, now A is a concrete class. Let's see the scenario now. Class Z is there. It is having some methods, void M1, void M2. So this is how your class Z is there now. Now what is, class A is there. I'm explaining this concept. Class A is there. Understood? Now what is interface trying to do? Or what will I do? I'll write it here. Interface Z is trying to extend, it will not allow you. It gives you error. Why you know? Very simple. Concrete things you are trying to do what? Unclear. Very simple justification. Why you want to make a concrete thing into an unclear thing? Similarly, it cannot also implement a. Means when something is concrete, why are you trying to change it? Understood? But in Java they say a class can do, means a class can implement an interface, but an interface cannot do anything with the class. That's what they say in Java. But technically why I am explaining you? Because a class is concrete and interface is abstract. Now why do you want if you relate an interface and a class like this, a concrete thing you are trying to make it as what? Abstract. There's no meaning in that. Unclear things making concrete, agreed. But why do you want to make a clear thing unclear? As simple as this. Clear? So write down all this. We'll see more of interface in the next class. You understood the relationship now? Class extends as, interface extends interface, class implements interface. But interface cannot do here. Interface dash class. Nothing. Nothing you can do. That syntax is wrong. In the interview they'll give you all these questions. Interface dash class. So you should be comfortable. You cannot do anything with that. Okay, that's it then. Any questions you're having for the day? Okay, we'll see more of interface next class.